In this video, we're going to talk about MAT0028, rational expressions, and we're going to be adding and subtracting them. So we're going to start off talking about least common denominators, and then we're going to finish this part of the video with dealing with denominators that already match. But I don't want you to think of it as different sections have different rules. These are the rules for any problems that are adding and subtracting. First step, you need to think of it as we are building them to match. We want to get the LCDs, so we're building them to match. Once they match, we can go to step 2. Once they match, you'll notice I put the words keep the denominator, add or subtract the numerator. Once there's a single fraction, that's when we're back to what we did in the very first portion of this module, where we want to factor everything and see if it cancels. So I want you to stop and look back. We are not concerned with what's in the numerator and factoring it until the very last step. We are going to factor the denominator first because we want to make them match. Important piece here, difference. Multiplication and division, we factor everything. Adding and subtracting, we start off focusing only on the denominators. So we're going to start off looking at just how do we get the least common denominator? Refresh our memory. So the first problem, we have two monomials. Remember, a least common denominator is pulling every factor so that it matches, but we want the smallest amount to make it match. So if it's got any binomials or trinomials, we're going to have to factor, but we're going to start with just monomials. So remember, we're looking for, be careful, and I'm going to write it down over here beside it. A GCF is a greatest common factor. Factors are smaller. A least common denominator is actually a least common multiple. It just happens to be in the denominator. And a multiples are bigger. So it's very, very easy to confuse these words. Stop if you find yourself mixing them up. Factors are smaller. Multiples are bigger. So when we look at the number 4 and 8, the least common multiple between those is 8. Be careful. Y'all's brains right now want to think of factors, but we're going bigger, remember? I don't want to multiply them together. I want to use the smallest number that would work for both of them. When we're dealing with variables, we take the biggest exponent because that's the bigger amount that will make it match for all. So we will have a y to the 5th. That's my denominator. My least common denominator. It has nothing to do with the numerator. It says look at the denominators and compare. So be careful. You've done this before when we dealt with fractions. Now we're adding variables into it, but we're still taking, if I had the number 2 5 times, we would look for how many, the maximum number. Same thing for the variables. So now looking at number 8, I'm going to break it up. We're going to start off first looking at 5 and 15 since these are monomials. So the multiple between those is 15. For my x's, remember we take the bigger amount, so it's x squared. And for the y's, we take the bigger amount, which would be y cubed. Multiples, which is a least common denominator, we're building it, we're making it bigger. Number 9, this one's not quite as straightforward, but stop and look at 8 and 12. So I a lot of times will say, she does it differently than me. I would take 12 and say, what's the next multiple of 12? It's 24. Does 8 go into it? Yes. So that works. If it didn't, I would go the next multiple and then do it that way. There's multiple ways to do that, but that's one shortcut for doing those pieces. So now we're going to look at our x's. We take the bigger amount, which is x to the 5th. We look at our y's. We take the bigger amount, which is y to the 5th, and don't forget that there is a z squared here, and you have to bring that over as well because we have to include everything that's there, so don't forget that piece. So another way that they're going to ask this question just kind of is leading us in the direction of, okay, what do we do if we have an LCD? So if we're trying to make them match, how do we make them match? So remember, as long as you multiply both the numerator and denominator by the same value, you're not changing the value. It looks different. So to get to from 5y to 20x squared y squared, 5 times 4 would give me the 20. There's no x values on the left side, so we would need to include them all. There's already a y. To get a y squared, we would multiply by y. So again, let's look back at that. 5 times 4 gives me the 20. X squared, y times y gives me y squared. Whatever I did to the denominator, I also have to do to the numerator. So 2 times 4 is 8. X times x squared, remember we add our exponents, so that gives me x cubed. And bring the y. That's my answer. Whatever you do to the numerator, you have to do. So remember, we're going to now go to sum and differences. We're going to use the ideas we just talked about. So reminder, and this is actually more in-depth direction. So I had given you the 3 steps above, but this is where I want to, again, just go a little bit more into detail. First step, we're building the denominators to match. We are only looking at the denominators, so we're going to factor every denominator, find the LCD. Again, I've written out what that is defined to be. I really strongly recommend you simplify separately first before you try to combine them. Second step, once the denominators match, we're going to keep the denominator. We keep the denominator, which is my LCD, and we're going to add or subtract any like terms in the numerator. Once it is a single fraction, that is the only time we're going to factor the numerator. So I'm going to keep reminding you this. We're factoring every piece if it's multiplication and division. If it's adding and subtracting, we start by focusing only on the denominator for factoring until the very last step. So let's start with number 11 here. In this case, my LCD looks at the denominators. They already match, so my LCD here is 2q. That already is there, and I'm going to keep reminding myself that I want to keep that. So we keep that denominator. We add across the numerator. So you need to ask yourself, are there like terms to add? And in this case, there are. 3 plus 11 should give me 14p. This is where you got to be careful. A lot of people, oh, that's my answer. You did the hard stuff right, but once it is a single fraction, which is right here, single fraction, can you cancel anything by factoring? 2 goes into 14 7 times, so I can simplify that piece. It gives me 7p over q. All right, going to number 12. I do realize that they already match, but I want y'all to get in the habit of when you see adding and subtracting, we're going to go ahead and factor the denominators. So this is going to be an x. Please be careful. So a lot of people make the mistake with 6, and they see the 5, and they say it's 2 and 3. But these signs have to be opposite. So this one actually is x plus 6 and x minus 1. I think the number 6 is the most common one that's missed with the number 5 because you aren't careful with your signs. If I did a 2 and a 3, they would have to match to give me the 5. So I factored those, and again, I know I did that kind of quickly. Just make sure you understand how I got that. So in my LCD here, they already match. The x plus 6, the x minus 1. We're going to keep it. That's my goal. So I'm going to go ahead and write that down. This is where we got to be careful. Subtraction, remember, means that we have to add the opposites. This sign has to go to both pieces. Don't fall in the trap of not changing your signs. This should be a minus. This should be a positive because it's a -1 times that whole numerator. So now I have 3x minus 2x, which gives me a 1x. I have a -1 and a +7, which is going to give me a +6. Now that it's a single fraction, ask yourself, can you cancel anything by factoring? This numerator, I can't factor anything, but I'm going to put the parentheses there because the x plus 6's match. So I'm left with 1 over x minus 1 as my answer. Be careful. Don't do everything hard correct and forget to do that last step. So going to number 13. Denominators already match. So my LCD here is 10y, and I'm going to keep it. So the 10y stays. 9 minus 3. 9 minus 3 is 6. It's a single fraction. So can I cancel anything? 2 goes into both the top and the bottom. So I get 3 over 5y as my answer. Please pause this, rewind it to watch any of these again. But I'm going to keep repeating myself. When you're doing these problems, your goal is to get an LCD and keep it. So going to number 14, the last one for this video. Denominators match. So I'm going to go ahead and put my parentheses there just so we're clear. Y minus 2 is my LCD. We're going to keep that. So the y minus 2 stays. This is one you got to be careful. We have 8y minus 16. Those are not like terms, meaning I can't add anything together, but you are expected to rewrite it all in the numerator as a single fraction if you can't add them. We're going to write it always in descending order. Now that it's a single fraction, look at the numerator and ask yourself, can you factor? I can pull out an 8. That leaves me with a y minus 2. Now they match. The y minus 2's cancel. I am left with the number 8 over 1 because the 8 is in the numerator. You are expected, we never leave a 1 in the denominator. My final answer there is 8. These are problems that you're going to find in the first section where the denominators already match. You're going to be able to do the adding part pretty quickly, but be careful on the finishing part of simplifying. Y'all want to skip steps. Think of it again as 3 steps. LCD, keep it. Once it matches, put the numerator together. Keep the denominator. Once it's a single fraction, can I factor the numerator and cancel?